Hi, so I'm happy to introduce Thilina, who will talk about Azure and also the implementation of Twister on Azure. And thank you very much for Plan B.
Hi, good evening, good afternoon. I'm Thilina. So today I'm going to give you guys a overview and an introduction to Azure Cloud Platform. So this presentation will be followed up by a presentation on Twister for Azure, which is a iterative MapReduce framework which we developed for the Azure Cloud. Let's see. So I'm not really gonna go into what is a cloud. I'm sure you guys have heard enough of it during the first couple of days. But if we have a quick look at the left side graph, we can see a typical data center environment where you have deployed a certain amount of compute resources, but the issue is oftentimes the demand is not predictable. So there can be times where you are under provisioned, so affecting the service performance, and then there can be times where you are over provisioned, which cost you money. So in the right hand graph, you see a scenario where we use cloud for the same application, and then in here we can see the compute resource, the amount of compute resource we're gonna use exactly follows the, more or less follows the demand pattern, because we can deploy and undeploy and dynamically provision the resources any way we need with the cloud. I mean, saving both money as well as increasing our application performance. Sure. Okay, we have another break. Okay, hi. Sure, thanks, Barbara. So let's have a look at the cloud computing patterns. I mean, the patterns of computing that might be useful to be done with clouds. So the first is the pattern where we have on and off computations. So this is your typical batch job. And then we have computations that can grow very fast. So you can think of a computation like this as a viral Facebook or an iPhone app or Android app, which can get picked up very fast. So, and then the third type of application that we can think that's very suitable for the cloud is where you have unpredictable bursting of the usage. So you can think of this as your website getting /dotted. The fourth type is where you have predictable bursting. So this is similar to, I mean, you can think of this as a shopping website where you have predictable burst during the holiday season. I mean, if you think of Amazon.com having a lot more load than throughout the year, having a lot more load in the holiday times. And also you can, the same scenario with the NBC Olympics example Jonathan mentioned yesterday. So it's a predictable burst. So these are the four scenarios. These are four scenarios where cloud can be useful for you in terms of performance as well as money. Okay, let's have a quick look at the cloud terminology. So in the current definition, we have three types of services. So the first is the infrastructure as a service clouds. So these provide on-demand virtual servers, and you have to take care of all the things in your VM and above that. So whatever the underlying hardware and the network and those things will be taken care of you. So you will be responsible for maintaining your OS, doing updates, taking care of your firewalls and etc. But you don't have to worry about the physical compute resources or the network. The next type is the platform as a service clouds. So in there you get the provider provides a managed environment to host your application. So this environment provides this environment provides resources and services for your application, and you don't need to worry about like the operating system or the other services you're going to use in that environment. So in a platform as a service environment, you just need to worry about your application logic or developing your application, and almost all the others will be taken care of by the environment. So the fourth type is the software as a service cloud. So in there, the provider provides the application itself. So you only have to worry about using the application and then maybe paying your bill when it comes. So So this slide further elaborates what we're talking about. So if you look at infrastructure as a service, you have to manage your middleware, runtime, data, application, etc. And in a platform as a service, you just have to manage applications and data. And then when you go for a software as a service, everything is managed for you. You just have to pay and use the application. And then, so in this diagram, when you slide towards the right side, towards the software as a service, your efficiency increases because you don't have to worry about all the manual maintenance tasks, but so do the cost. So the cost also increases. And then when you go to the left side towards infrastructure as a service or your typical data center, and then the cost would be less, but you have a lot more work to take care of, a lot more maintenance to take care of. So lately we've been seeing convergence of this landscape. I mean, we've been seeing traditional infrastructure as a service providers coming up with platform as a service offerings, and then traditional platform as a service providers like Azure, Google, coming up with infrastructure as a service offerings. So we can think like most of the commercial cloud providers would, in the future, might offer all these types of clouds. So to quickly highlight the point, so if you think of a MEC application that's deployed in cloud, so if you are going with the infrastructure as a service, you have to deploy a VM, set up your database, then deploy another VM and prepare the VM for your application and deploy the application, and then provision the database, create the tables, and then install the application in the application VM you created, and then configure the load balancer. And when the application is even up and running, you have to make sure you maintain it. I mean, you have to check whether the database server is running out of space and all these maintenance tasks you have to take care of. But when you go to a platform as a service, you just provision the database using their database service, and then deploy your application. Everything else would be taken care of. Everything will be taken care of by the platform as a service provider.